that I'm giving in this series, including this one. Not only are there links to the videos, but there's also downloads for slides and for demos for some of the presentations. And you're going to want to download those because in these presentations, I give a lot of links to additional resources, and those links are going to be available in those slides. So to get started on the topic today of developing large LabVIEW projects and troubleshooting issues that happen with those, first I'm going to talk about some common development pitfalls. And the first one I want to describe is moving a project from one system to another. Now you've got a system that is set up with a bunch of probably LabVIEW software and probably NI hardware. And what kind of issues can happen when you need to move that system over or make a copy of that system? One of the most common ways that LabVIEW developers will sandbox their applications to make them easier to move from one system to another is a virtual machine. Now, I do know some LabVIEW programmers who keep all of their projects on a single development computer. I honestly don't understand how they can do that because of the, if nothing else, just the different driver versions that are needed for different versions of drivers that you're using with different projects, presumably, but some people do it. In my experience, virtual machines make it a lot easier to have a single place with just the right software and just the right drivers to be able to work on a specific application. If you've never used virtual machines before, it is basically a concept of running an operating system within a sandboxed environment on your development computer that has its own operating system, right? So VMware Workstation is one of the most common VM software packages available. There's certainly lots of others. I use VMware. And what it does is it gives you an application that you run on your computer, and you load up a virtual machine and start it, and it basically boots up a system within the sandbox of the VMware Workstation application. The reason I find these helpful is because it's really nice, as I mentioned, to have a sandbox with these specific versions of software installed where I need. It's very easy to make backups of virtual machines. There is backup functionality built into VMware. You could also very simply, zip up your virtual machines because they're just files on your computer and have backups that way. Especially if you use source control, which you should be using. If something terrible happens to your virtual machine, it's usually pretty easy to spin up a new one with the right software on it and the right drivers and just pull down your code from whatever source control software that you're using. Now, all that being said, if you go to the NI.com knowledge base, there is an article, I have it linked on the slide, that says NI does not officially support using NI software and hardware with VMs. I mean, it's there on the website. Despite this, a ton of LabVIEW users still use virtual machines, even though it's not officially supported by NI, just because of how powerful it is to sandbox those applications. So just keep that in mind. If you're running into issues, you've got a project that uses LabVIEW 2019 and NI-DAC-MX 19, and all of a sudden you've got a new project that needs LabVIEW 2018 and NI-DAC-MX 18. You can't have multiple versions of that driver installed on the computer. VMs are a good way to get around that limitation and be able to work on those projects independently without having them interfere with one another. So that's my spiel on VMs, I guess. Now let's talk about the LabVIEW project itself. When you're working in a project, how do you organize the project? Well, under your any target in the project window, in this case we see my computer shown in the slide, you can have folders, you can have libraries, and then there's the dependencies node. And those are the things that you'll see under a given target. So just to give a little bit of a glossary here, because I'm going to be throwing around a lot of terms in this part of the presentation. A LabVIEW project library is a .lvlib file. It is a single file that organizes your source code, but the source code is not contained within the project library. So a .lvlib is a single file on disk. It's an XML file, in case you're curious. And within that file is basically a list of all of the VIs that are members of that library. And those VIs are separate files on disk. When I use the word library, I'm pretty much talking about an LVlib, a LabVIEW project library. Then we've got classes. A LabVIEW class library is a type of library. It provides the same functionality. It allows you to organize your source code. It's a single file on disk, but it also provides additional behavior related to object-oriented programming in LabVIEW. If you've got VIs and classes, then you can have things like override VIs, private member data, stuff like that. If I say the word class, I'm referring to a class library, a .lv class file. And then there's the packed project library, an lvlib.p file. Now, remember, an lvlib is a single file that does not contain the source code. And lvlib.p is a single file that does contain the source code. It's basically a build output in LabVIEW where you can point LabVIEW to an lvlib and say, turn this into an lvlib.p for me. And it will be a single file with a .lvlib.p extension. And within that file are all of the member VIs of that packed project library. And it's going to have a different namespace than the original library. So if your original library was called a.lvlib, and the VIs in that library are going to be namespaced to a.lvlib. When you build that library into a packed project library at PPL, then now the namespace is a.lvlib.p. So it's a different namespace. LabVIEW considers those different named VIs. Anyway, so I'm going to be saying library, class, and PPL a lot in this presentation. So I just wanted to clarify what those terms were if you weren't familiar with them. All right, so when you're organizing a large, complex project, you're probably going to use folders, right? It makes sense. And some LabVIEW programmers like auto-populating folders in the project. If you have an auto-populating folder, you can point the project to a folder on disk and say, I want the project to remain in sync with this folder on disk. So if I add a file to that folder on disk, I will see it show up in the project and vice versa. Now, there's some problems with auto-populating folders. A lot of LabVIEW programmers don't like them. One of the main problems for me is that there are these gray areas where the organization in the auto-populating folder in your project will not match necessarily what's on disk. And the most common example of that is a library. So if you have a library sitting inside of an auto-populating folder on disk, that library is going to show up in the project under the auto-populating folder, but then within that library, the VIs are going to be organized as you've defined them for the library, not as you've defined them on disk. So right away, we've got this ambiguous situation where we can have an auto-populating folder in the project that doesn't necessarily reflect how things look on disk. And I find that confusing. In my experience, just to avoid issues like this, I pretty much only use auto-populating folders if I'm dealing with a folder of like template files or VIs that are dynamically loaded by something. And usually these VIs are not members of libraries. They don't have a separate namespace. And so it's very easy for me to dump things into that plugin folder or that template folder and have the current contents of that folder always represented in the project window. Now, if you're using a regular folder, also called a virtual folder, it's not auto-populating. It is not linked to the contents of the disk. But now you have to manage the contents of that virtual folder. So now it's your responsibility to keep things organized within that virtual folder since it is not reflecting what is organized on disk. So you'll receive different types of advice on this topic from different LabVIEW programmers. My preference is that I very rarely use auto-populating, pretty much only for templates or plugin type designs. So another pitfall that can happen when working with large projects, definitely something I've had to troubleshoot a lot over the years, is cross-linking. Cross-linking simply means LabVIEW is linking to a VI that is different than the one you think it should be linking to. And this will usually happen when you've got multiple things open and you open a new VI or a new project or a new library or whatever, and it references a VI by name, let's say a.vi again. Maybe my project within the folder of VIs that are working with my project is a.vi. Well, if I've already got an a.vi open that is located somewhere else, and then I open this new project, it is going to link to the a.vi that's in memory. It's not going to link to the one that is sitting in that folder with that project. And then if I save everything, now my VIs are linking to this a.vi that's in a different spot than the one that I think it's linking to. This can be a huge problem when working with projects, especially when things are being copied from one place to another. Oh, I've got this folder of VIs here, but I need it over in this project over here. Now you're working in this project over here, but you've accidentally messed up and you're still linking to the original location. It can be a huge mess. Now, how do you avoid cross-linking? Well, there's a lot of things that you can do. One of the things you can do that can help you prevent this issue or even troubleshoot it when it's already happened to you is to show item paths in the project window. So if you go to the project pull down, one of the options is show item paths. And then you'll see a project window that looks like the one in the slide here, where in addition to seeing the VIs as they're organized in my project, you can see I'm using virtual folders for this particular project. You can also see the paths to where those VIs live on disk. And if you sort of, as your eyes visually scroll that list of paths, you can very quickly see that there is one VI in this project that is not in the same folder as everybody else. And so if I hadn't noticed this, what I'd probably do is somebody might say, hey, I need a copy of your finite measurement project. So I'll say, sure. So I'll grab that folder on disk, the one that's in temp, C/temp/finite measurement. I'll just zip up that folder and send it to my friend. And then when he opens that project, it starts searching for a VI. And that's because on my computer, I've got this other folder, temp2, that happens to contain one of the VIs in this project. But that's not immediately obvious to me when I'm working in the project unless I have the paths list showing. So this is one way that you can sort of prevent some of those issues and quickly see, oh, wait, I've got a VI that's not in the spot where I think it should be. Another thing that you can do is go to the Files tab in the project. Most of us develop with the Items tab selected. In fact, that's the one that's selected in this screenshot here. But you can see next to the Items tab near the top of the project window is also a Files tab. And if you click on that, you'll see an organization of your project as it relates to the organization on disk. And that's another way where you could very quickly observe, oh, wait a minute, I've got this other folder, temp2, that contains one of the VIs in my project. I need to fix that cross-linking there. Another way to avoid cross-linking, and this is if you don't use auto-populating folders and if you don't use libraries, as you can see, this project is not using them, is you can use the option in the project window to add a folder from disk as a snapshot. So instead of adding a folder as auto-populating, where it will always try to sync the contents of the folder to the contents of the project, you can add a folder as a snapshot, and that will just one time, pull everything in from that folder into the project. And what that does is you can point that at a folder that you think already contains everything in your project and see if new things show up in your project. And if they do, then that means you have things in your project folder on disk that were not in your project, and that's probably not a situation that you want. So folder snapshot, another debugging technique, a troubleshooting technique if you're running into some of those cross-linking issues. My main advice, though, is to just use libraries. When you use a library and you move a library from one machine over to another, within the library, the namespacing sort of makes it so that you've got a very quick and easy way to identify this is the set of reusable code that I'm going to be using in this project and this other project. When you right-click in a project and do add an LVlib, the LVlib gets added to the project along with all of its member VIs. So there's no needing to make sure that this folder syncs up with what I think is supposed to be in it. Much less disk management required when you use libraries. Also, a word of advice, if you're using libraries, and this applies to also classes, in my opinion, and which are a type of library, all of the organization for the library should take place in the project. Don't spend a bunch of time on disk, in the folder of your library, making like a public subfolder and a private subfolder and a typedef subfolder. Don't do any of that on disk. All of your library members should be in a flat folder structure on disk, a folder that contains your .lvlib and all of the member VIs of that library. Leave the organization to the project window. Do your organizing of your library members under the LVlib entry in the project, not on disk. Your disk should just be a flat file structure for all libraries. That's my advice. All right, so another issue that can happen when working with complex projects is dependency management. So if your project calls a.dll and a.dll calls b.dll, LabVIEW is smart enough to pull in a.dll into the dependencies, but that's where the smarts end. LabVIEW doesn't do any sort of querying of the DLL to find dependent DLLs that also need to be dependencies. So if you depend on DLLs and those DLLs depend on other DLLs, you need to manage that yourself when you're moving projects from one place to another, or else you're going to have missing dependencies when that DLL tries to load. Same thing goes for LabVIEW files like VIs. If you have a plugin system where you have a main VI that is dynamically calling other VIs, you are going to need to manage those dependent dynamic VIs because the project window is not going to see linkages from a main VI and things that it calls dynamically. That's actually one place where, as I mentioned before, auto-populating folders can be helpful because that way your plugins always show up under the auto-populating folder in the project, even when you start to add new ones. And even when those, since they're dynamically populated, their linkages are not, LabVIEW's not aware of those. So a couple of tips for avoiding dependency issues, and with this I'm referring to LabVIEW file-based dependencies like VIs and type defs. Take a look at the dependencies node under your target pretty frequently. This is something that not enough LabVIEW programmers do, in my opinion. As you're working on a big project, check in with what you see under the dependencies node. Make sure there's not things showing up under there that you didn't expect to, like VIs from another project, for example, or VIs from shared, I guess, reuse libraries that you didn't realize you were using. Keep an eye on that. And if you want to, you can manage your dependencies more explicitly. It's very easy. In your project window, simply drag the libraries or VIs from under dependencies up into your target. So if you're on my computer, you can make a virtual folder called dependencies and just drag dependencies up into that. And now you're explicitly stating these are dependencies of my project without having to let the project window manage that for you. That's another way, and that's a way to communicate to other people that look at the project how you've designed it by sort of sharing with the world, these are the dependencies that I know that I'm working with on my project. All right, so after talking about some of those pitfalls, now I want to talk about, what actually do you do in LabVIEW to distribute an application, and what are some issues that can happen when working on that? So if you have to distribute source code, the most common way to do that, the NI recommended way to do that is with a source distribution. So some people will just literally zip up a folder and email it to somebody or put it on a shared drive somewhere. NI recommends instead that you explicitly create a source distribution. And there's a few reasons for this. One is that you can do a preview of the source dist. So when you set it up as a build spec and you configure, these are the files that I want to include in my source dist, the preview basically lets you know, here is what the code is going to look like when it is being distributed. It's also a great way to find out, as you're setting up the build, oh, wait, I'm cross-linked to some other stuff outside of my project. That is going to cause a problem if I try to distribute this code. Now, one word of warning, definitely an issue that I've had to troubleshoot before, is when people create a source dist, but they include VI-lib files or user-lib or insta-lib files in that source dist. You almost never want to do that because you're distributing source code, which means the person who's consuming this source dist has LabVIEW. If you start including LabVIEW core files, like files from VI-lib in your source dist, then when they go try to open it, they're almost certainly going to have cross-link issues between the VI-lib VIs that were included in your source dist and the VI-lib VIs that are already part of their LabVIEW. So unless you have some really strange corner use case, you almost never want to include those files. And that's a build option. That's an option in the source dist to say whether or not you want to include those files. By default, it's turned off. It's very rare that you would want to turn that on. So keep that in mind. I guess related to this, I would also say that making copies of files that ship with LabVIEW is a dangerous procedure. When you do it, you almost always want to save those copies with different names, and you want to make sure that you don't accidentally assume that you're saving a copy of something that has dependencies that you're also saving copies of. Be really careful when you save copies of things that ship with LabVIEW. And that's another thing, that if you find that you're having to solve a problem by saving copies of VIs that ship with LabVIEW, I could see that occasionally happening when you're trying to fix a bug, like with a VI, like you discover one of our math VIs has a bug in it or something. Instead of waiting for NI to fix it, you need it to work right now, so you save a copy. That I can understand. But any sort of, I'm going to solve this code distribution problem by saving copies of LabVIEW files, you may be heading down the wrong path there. All right, so VI packages. I really like using VI packages as a way of distributing my LabVIEW code. If you've never used VI packages before, they are basically files that are installed with VIPM. VIPM is a product that installs with LabVIEW. If you ever download an add-on from the tools network, you're using VIPM to do so. And VIPM usually installs libraries of VIs. If you've ever heard of OpenG, that's a toolkit of useful VIs installed via VIPM. Those things almost always get installed to VILib or userlib. Now, there are tools that are installed through VIPM that are like, tools for the LabVIEW editor that get installed somewhere else, but usually you're using VIPM to install reuse libraries that you're going to use in your application. Now, not enough people know about VIPC files. There are many times where I have to troubleshoot an application and I'm given a list and someone says, here, install these 15 things from the tools network. And inevitably, that list of 15 things should have been 16 because there was one dependency they forgot about, and I don't figure that out until I've installed everything, tried to load the giant project, and now I'm still getting prompts for missing VIs. It's really irritating. And there's a really simple solution that a lot of people don't know about, which is a VIPC file. A VIPC file is simply a specification of all of the VI packages that are dependencies for a project. And you just manage that as the owner of the project source code. And you always want to keep your VIPC file up to date. And now, when you are contacting me and saying, hey, Darren, help me out with this problem I'm having with my big application, it's got a bunch of dependencies installed through VIPM. My first question is going to be, where's the VIPC file? That way I can apply the VIPC, get all those dependencies installed, and start working and not have to worry about missing toolkits that you didn't tell me about. So I can't stress enough how useful VIPC files are for managing VIPM dependencies. Now, unfortunately, they are not, they don't solve the whole problem. VIPC files do not manage dependencies that are like LabVIEW modules or drivers or toolkits or anything like NI-made toolkits, drivers, things like that. But it's definitely a good start for any project that has dependencies that are installed as VI packages. Now, if you want to distribute your LabVIEW application, one of the ways that has been used for the past many years is the installer build spec. So if you look in the screenshot there, you'll see it's the second item in the list. And with an installer build spec, you can basically take your build outputs, which are usually EXEs, PPLs, and DLLs, and make an installer for those and give somebody an installer. They run the installer. It installs your application along with the LabVIEW runtime engine and any drivers that are needed. That's what we've been using for many years. Well, a few years ago, NI introduced the concept of NI packages. NI packages allow you to accomplish the same thing, but it's different technology under the hood. It doesn't use MSI-based technology. It uses NI package-based technology. So going forward, NI recommends using NI packages for distributing your code. At some point in the future, NI may actually deprecate the installer build spec in favor of NI packages. So keep that in mind. Now, what if you need to distribute a project that for someone that's using an older LabVIEW version? There is a feature in LabVIEW to save for previous, which you can do at any level in the sort of hierarchy. You can do it to a VI or a library or a project. When you do a save for previous, files that ship with LabVIEW or ship as part of drivers or VIPM packages, in other words, things that are in VILib, InstruLib, and UserLib, those files are not included in the save for previous. Now, one troubleshooting issue that I've seen when people do save for previous is they'll save for previous, and the resulting project just has a really strange file organization on disk. And there's one of those reasons could be because of cross-linking. Your project is not linking to the things that you think it should be. But another common reason I've seen is, as much as NI tries to discourage this, LabVIEW programmers will sometimes link to files that ship with LabVIEW that are not in VILib, InstruLib, and UserLib. The most common times that happens is VIs that are in the help folder and VIs that are in the examples folder. And if you save for previous a project and you are accidentally linking to, or maybe intentionally, linking to something in the help folder or the examples folder, then when your save for previous output is going to have some weird file organization because of those files that were not in those known locations. So this is another place where using the files view in the project can be handy to make sure you've got a handle on where your files are on disk and what things you're calling and where they live and which ones possibly live in the LabVIEW folder before you actually do the save for previous operation. All right, so last part of this presentation, I'm going to go into a little bit more detail about working with libraries. Now, the easiest way to describe a library is that it is a way to organize your VIs into public VI calls and private VI calls. Now, what does that mean? A public VI in a library is callable by things outside the library. So if you give me an LVlib and there are any VIs in there that are public, I will be able to call those in my own code outside of your library. This is the default scope whenever you first create a library and first create VIs within it. They will be public by default. Now, since they're public, since anybody can call them, if you ever change the interface of that VI by doing things like removing terminals or changing the connector pane pattern, anybody that calls that VI will break because now they were wired to a terminal that's gone, or if you change the connector pane pattern, now it's going to require relinking to the sub VI. Now contrast that with private VIs. So in a library, you can change the scope of a VI from public to private. There are some other scopes as well, but I'm not going to go into those in this presentation. For the purposes of this presentation, let's just talk about public and private. And in this case, someone who tries to call a private VI outside your library will not be able to. If there's a VI in your library that's private, and I try to drop that on the block diagram of my own VI, my VI is broken because I'm not allowed to call your private VI. Now, why would you spend the time to go through a library and decide which things are public and which things are private? The reason is that private VIs are internal VIs to your library that you can change whenever you want. You can add terminals, remove terminals, rename the VI, change the data type of terminals, basically do all sorts of things that will change the interface to that VI. And since it's a private VI, you're guaranteed that nobody outside the library is calling it. So you're guaranteed that you're not going to break any code outside the library when you change those interfaces to a private VI. If the VI is public, there is no guarantee of that. A cautionary tale on this topic was back in, I want to say LabVIEW 2009 or so, maybe plus or minus a year there, but NI changed the configuration file API that ships with LabVIEW, you know, the one that lets you make INI files. We changed the guts of that API. The VIs that were on the palette were still the same. You know, you called those, everything with those was fine. But underneath, there were a lot of changes made. Well, there was one VI in particular in that library that was changed completely in terms of its interface and maybe even its connector pane, I don't remember. It was a VI that had to do with string parsing. That VI should have been a private VI in the library, but it was not. It was a public VI. And over the years, the several years that this API existed, lots of LabVIEW customers found that VI, found it useful because of whatever string parsing functionality it did, and started calling that VI in their code. And then when they upgraded to LabVIEW 2009, all of these customer applications broke because people were calling a public VI in the configuration file library that should have been private all along. So this is why you want to spend the time deciding which VIs are public and private. Because if you've got a public VI in your library, you need to assume that anybody can and probably will call that VI at some point, and you don't want to break their code at a later time by changing that VI. So one very useful tool that I wanted to mention in this presentation is the class dependency viewer. So I've got the link for it there up on the page. It's a free tool for providing sort of a graphical analysis of how classes depend on one another in a project. Now, why is this tool useful? Well, one problem that can happen when building LabVIEW applications is when you have circular dependencies between classes. So if I have a class that calls class A, and it has a VI that calls a VI in class B, but class B also has a VI that calls a VI in class A. That's a circular dependency. Those two classes have dependencies on one another. The LabVIEW editor does not prevent you from doing this. You can do this in your code. You will not get broken VIs. You will get runnable code. But circular dependencies in classes is one of the most common reasons I've seen for people having build issues, particularly really long build times, like a build that you would expect to take, a matter of seconds takes a matter of hours because somewhere in the classes, build that would take minutes, let's say, would take hours, because somewhere in the class linkages in this large project, you've got a class calling VIs from another class and that class calling VIs from the first class. This tool that I have on the slide here is very useful for troubleshooting those type of applications and finding places where those circular dependencies exist. All right, so I've talked about PPLs a few times in the presentation so far. Unfortunately, PPLs can be a big cause for problems when building LabVIEW projects. Now, why do people even use PPLs in the first place? The number one advantage I've seen is for large applications that have a modular design. If I have a huge LabVIEW application with thousands of VIs, and all of those VIs are statically linked within the main application, then when I build that as an EXE, it has to pull every single VI into the EXE and do that build. If I make one little change to one little VI, I still have to rebuild the entire executable because it's a monolith. All the VIs are called by this one EXE. Now, a lot of LabVIEW programmers with large applications have had great success avoiding this problem by using PPLs. And what they'll do is they will have, several, possibly dozens of PPLs that are the modular pieces of their application. And they have a main EXE that is calling VIs inside of those PPLs. Now I have to change that one little thing, remember? Well, if that's inside of one of these PPLs, all I have to do is rebuild that one PPL. None of the other PPLs need to be rebuilt. The EXE itself does not need to be rebuilt. And now I've got much shorter build times and deployment times because I'm just changing one piece of this small modular part of my application as opposed to the whole thing. And another great thing about PPLs, a lot of LabVIEW build types are version dependent. For example, if I build a EXE in LabVIEW 2018 and try to run it on a machine that has only the LabVIEW 2019 runtime engine, it won't work. But there is a feature in LabVIEW that lets you build things and allow future versions of LabVIEW to load them. So when you use PPLs for your file and EXE organization, you can select this option in the build spec of the PPL. And now, the computer that's running the application could have the current or any future runtime engine installed on it and still be able to load that PPL. So a big advantage of using these. Now I mentioned that a lot of people have problems with PPL projects, and here are some reasons why. PPLs are not supported cross-platform, so if I build one on Windows, it will not work on Mac. If I have to make an update to any sort of public call in the PPL, I do have to rebuild it. Sometimes, so PPLs pull in all of their dependencies. So if you have a PPL and it has VIs that call VIs that ship with LabVIEW and VI-lib, it's going to pull those in. So if you have 20 PPLs and all of those have dependencies on files in VI-lib, all of them are going to pull in copies, which makes all of them bigger, which makes load time higher. I have seen people get around this by actually building a PPL that contains the shared pieces of VI-lib that all of their code calls. And then all of their code calls the copies in the PPL instead of the ones in VI-lib. Yeah, so that's a few of the caveats. But the biggest issue I have seen working with PPLs over the years is when someone has an EXE that calls dependent PPLs, they do all their builds of the PPLs, they do their build of the EXE, and when they run the EXE, search dialogues come up for files inside the PPLs. This is the most common PPL build issue I have seen over the years. Thankfully, one of my colleagues at NI, Derek, has written an article on NI.com that describes why this happens and how to fix it. And I've got a link for his post here in the slide. If you take nothing else away from this presentation, if you don't agree with anything I said, or you find all of this stuff not useful, please take away this link. It's extremely important. And if you ever build with EXEs and PPLs, you will run into this issue, and you definitely do want to read Derek's article. So here are some recommendations I have for working with PPLs. These are things that I sort of have had in my back pocket that have sort of been building up over the years as, these are ways to avoid some of the most common PPL issues. First of all, every single PPL in your source code should be built from its own project. You should have a single project per library that is built into a PPL. When you build those PPLs, build them into a common root folder on the system. Ideally, all of your code is going to run from C drive, because that's another issue when you start to have code running on different drives. You run into some issues with absolute paths. Ideally, your code's going to run on C drive, and your PPLs are all going to be stuck in a single root folder. You can see I have my company PPLs. Just stick all your PPLs there. And then my last recommendation, when you build any EXE or DLL or PPL that depends on PPLs, make sure to go into the additional exclusions page of App Builder and select the exclude dependent packed libraries option. What that does is that basically makes it so that all of your builds link to the PPLs that are sitting in that common root folder. So if you follow these recommendations, I'm not guaranteeing you won't have problems, but you will probably have less problems. Another tool that's useful for projects that are heavily based on PPLs is the MGI Solution Explorer. This is a tool that ships with LabVIEW 2020 or later. It is a free download if you're in a previous LabVIEW version. And it's basically a way to manage all of the builds in your project. Now, you may be wondering, I've got the build specs in the project window for managing that. Well, remember I said before that each PPL should be its own project? The Solution Explorer is a tool to manage builds that's higher than the project level. And this is where you can configure all of those, build this PPL first, then this one, then this one, then this one, and, run any post-build scripts that you need. I highly recommend using the MGI Solution Explorer on any project where PPLs are used. So hopefully I won't get in trouble for this slide here, but in my experience, if you have a large LabVIEW project and you're building some substantial build output like an EXE or a PPL, and you have problems, you get broken code after the build, you get an error during the build, you get missing files when you try to load the build output. In order, I think that the following features in this slide are likely part of the problem. Malleable VIs, PPLs, X controls, channel wires, and classes. I hate to say it, but it just seems that these features are more likely than not causes of build issues. And whenever bug reports get filed to NI investigates them and fixes these issues. I can say with certainty that malleable VIs are definitely more stable in LabVIEW 2020 than they were in LabVIEW 2017. Nevertheless, these bugs are still being found. So keep an eye on these particular problematic features. If you are doing a build and you find that you're having issues with it, try to isolate the issue. For example, write a scripting tool that goes through and replaces all the malleable VIs with instance or with sub VIs. See if that helps. Remove the part of your code that has the X control and see if the build works then. This isn't a way to solve the issue, but it's a way to troubleshoot the issue and get it down to which problematic feature is causing the problem. A couple of other additional tools for narrowing down and troubleshooting project issues. Some LabVIEW builds of PPLs and EXEs take a really long time to build. And sometimes the cause, if that build errors out, sometimes the cause is that you've got a broken VI in your project somewhere. LabVIEW 2019 and later ships with a VI that you can point at your project and run it. And this VI runs in a fraction of the time that a typical build takes. And it will tell you if there's any broken VIs in your project. And that way you can go fix those before you try to kick off the long build that takes 2 hours only to come back and tell you after 2 hours that something was broken. Another tool, and again, I hesitate to recommend this because basically what this is working around bugs in LabVIEW, is to play checkbox roulette in App Builder. So those 5 checkboxes there on the additional exclusions page in App Builder, I've seen more times than I can count that a build that generates a broken exe or a build that errors out due to some cryptic error, playing around with those checkboxes can sometimes fix the problem. Now I say fix, obviously there's a bug in LabVIEW that's causing the problem, but playing around with those checkboxes can get you an exe that runs, which a lot of the times is what you need when you're crunched for time. You know, get the bug report filed to NI at some point, including the project that causes the issue. But if you need a build today, then play with those checkboxes, play checkbox roulette, see if you can get a winning spin and get your build to work. A few other things you can try. I've seen many cases where when you build an exe and it turns out broken, if you go enable debugging in the app builder settings for the exe, you'll get an exe that runs. I have also seen the opposite, where an exe with debugging enabled broke the exe and turning it off made it run. So that's another thing to try. One of the most common causes that I've seen for code that runs in the environment but is broken as an exe is when someone has a conditional disable structure and that structure has a runtime engine equals true case and there's broken code in that case. That's the kind of thing you could write a VI analyzer test for to try to detect, but that is one area you want to look into. If you run the VI and it runs fine, but you build an exe and it's broken, look to see if there's any conditional disable structures with broken code in them. You want to try mass compiling your code if you have issues. The compiled object cache, if you're using source only, can be refreshed by mass compile. If you're not using source only, you should be using it. That's the option to separate compiled code from source code. That is often going to fix some issues with App Builder if you have that setting enabled on your entire project. And then as a last resort, if you are using source only and you're having problems with your build, clear the compiled object cache and then do a rebuild. That can sometimes fix issues as well. So to summarize, when you're organizing your project, to avoid issues with cross-linking and breaking people's code, you should really consider using libraries if you don't already. And when you do use libraries, make sure to, for every VI in that library, decide if it makes sense for it to be public or private. You're saving yourself time down the road for when people call your public VIs that you never intended to be public in the first place and their code starts breaking. If you need to distribute your source code, make sure to use a source distribution, especially with the preview feature in App Builder. It's the best way to figure out what the code is going to look like and if you're going to have any issues with missing or cross-linked VIs before you distribute it. Once you do have code that you need to distribute, maybe not necessarily source code, but things like reuse libraries, you should use NI packages and VI packages to distribute those. Don't forget about using a VIPC file. Keep your VIPC file up to date with your project. So whenever somebody else needs your project and starts working on it, there is an up-to-date list of the VIPM dependencies. And then make sure you're aware of some of these build issues I talked about with problematic features, checkbox roulette and App Builder, all of those other recommendations. Now your homework here. These slides are available at bit.ly/dnatlv troubleshooting. A video recording of this presentation is also available there. And if nothing else, please go read Derek's article about PPL dependencies. It is a great resource for an issue that I've seen happen time and time again with PPLs and search dialogues. You definitely need to read that article. I'm so glad that he wrote it. That is all the content I have for this presentation. Thanks so much for your time. I hope some of these techniques in here are going to help you with your troubleshooting of large LabVIEW applications in the future. Thank you.